right. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good afternoon, student, everyone.
Good afternoon, sir.
How are you today? Are you fine? Thank you. Good. Okay. So welcome to MSc lesson 16.
Fine.
Now we are in lesson 16. So as usual, before we start our lesson, let's pray. Pray begins. Pray finish. Okay, guys, please don't forget to fill in the attendance. Okay, you know already the link, the attendance. I give you 1 minute to fill the attendance, and I can share also the link here again in the chatting room, so everybody can access the attendance. All right, so that's the attendance link in the chat room. You can see. Don't forget to fill the attendance. Now I'm going to share my screen. Okay, so before we start the lesson, I have to turn off my video because if I'm turn on my video, I couldn't write here because the connection is not good here. So again, please don't mind if I turn off my video so we can write in the presentation. Okay. Okay, can you see the screen?
Yes, sir.
Okay, good. So this is Camson lesson 16, video conference, August 25th, 2020. Okay, so again in this lesson, we are going to continue with the Bohr's and modern atomic theories. It is the continuation from the last week lesson, yeah. Don't forget, we learned about Bohr's mainly last week. If we want to review, this is what we learned from last week about Bohr's atomic models. Bohr said that the first one, electrons are found in certain places, so-called energy level or shell. So this is the cell, yeah, and it is the electron are found in that cells, and then electron move in its stationary state in circular phase. So this is what Bohr says: the electron are moving in circular phase. And then when an electron falls back from the higher to the lower, then there will be energy emitted. And the opposite, when the electron are jump from the lower energy level to the higher energy level, then the energy will be absorbed. So this is what Bohr say, postulate number 3. And number 4, Bohr say that the name of the shell can be stated by letters starting from K, not A, K, L, M, N, O. And also it can be stated by using numbers. N is equal to 1, 2, 3. Is to show you that if N equal to 1, the first cell, N equal to 2, the second cell, and so on. So this is what we learned about the Bohr's atomic models. And today we are going to continue with the modern atomic theories. Yeah, still we are related with the history of the atoms. What is important here, guys, actually the modern atomic models is the revision of the Bohr's atomic models. So this is actually the revision of the Bohr's atomic models. Why? Because Bohr's atomic models, it is only valid here, is only valid for the atoms that have only one electron. Atom that have only one electron. So Bohr's atomic models, it is only valid for the atom which has one electron. But actually in the universe, there are so many atoms that has more than one electron. So how can we explain about the behavior of the electron in the atom that has more than one electron? So the Bohr's atomic theory must be revised. Yeah, the Bohr atomic theory must be revised. There must be a revision. And the revision of the Bohr's atomic theory is called as modern atomic model. This is the revision of the Bohr's atomic theory. Sometimes it is also called as quantum. Yeah, quantum atomic models, because it's related with the quantum. When we're talking about quantum, we are going to talk about something which is cannot be seen, something which is very small, and it is duality. Yeah, duality. Duality means that you cannot think the object as a particle only, but you have to think also object as a wave. So there is a duality in here. In the quantum, we are going to talk a little bit about this, about duality. So we will think that the object not as a particle only, but it is also as a wave. Okay, so this is the quantum. Okay, let's continue then. Sorry. The modern atomic models, the pioneer of modern atomic models, there are three scientists. The first one, it is named Louis de Broglie. Although it is written de Broglie, but actually how to pronounce his name is Louis de Broglie. Louis de Broglie came from French. And then the second scientist is Heisenberg. And then the third scientist, it is Scrodinger. So actually these three scientists work not together, they work separately, but their theory are related to each other, and we what sum up all the theory made by Louis de Broglie, Heisenberg, and Schrödinger as a modern atomic theory or quantum atomic theory. Yeah, this the job of these three guys is made a quantums. Okay, so we are going to see one by one. We are going to start with Louis de Broglie and then Heisenberg and Schrödinger. Louis de Broglie is famous with the duality. Like I told you in the previous slide, it is called about duality. What is duality means? Duality means that the object, the small object, yeah, the small object, we are talking about small object, atom is a small object. You have to think it is as a particles, this is the first one, and sometimes show wave-like properties. Sometimes it is also showing that wave-like properties. So in duality, we have two. The first one, we are talking about particles. And the second one, we are talking about wave. These two things are different, particle and wave. But we have to think both of them when we are talking about quantum. So when we're talking about quantum or quantum atomic models, then we have to consider both of them, particles and wave. Okay, so this is stated by who? Stated by Louis de Broglie. We're going to see what Louis de Broglie did with the experiment that he's think that the duality in the object. Okay, Is it clear, this slide? Any question? Okay, can we move? Okay, so let's move then. Okay. How to understand the duality in Alois de Broglie theory? How to understand duality? Duality means it has particles and as an object. When we're talking about the atoms, the small particle or the small object, then what's important in the atom? The important one is the electron. The behavior of the electron will tell you about the behavior of the atoms. So studying about the electron and its behavior is important to understand the atoms. Okay? So here, that's why we are going to talking about the behavior of the electron. The first one, sometimes it can behave like a particles. So this is a particle here, as you can see. There's a particle here. A particle means that something that like the thing that we see in our life, particle. For example, these particles, we can think that this is like a ball. Yeah, this is ball, small ball. Yeah, okay. Now, if we sort, the small ball into a slit that have two holes, one hole here and the other hole in here, it is called as a double slit experiment. This is called as a double slit experiment. Why it is double slit? Because it has two holes here. When we have a particle, think about this like a ball, small ball, yeah? When you saw the small ball will goes to the hole because we have two holes here. Then the small ball will be accumulated in the screen here, yeah? And we will have two accumulation here. Why? Because we have two hole here. So the ball will goes to the hole and it will accumulated in the screen here. So we will have two ball here. So this evidence, it is show you that it is a particles. If your things, it is a particle, an object is a particle, so it will behave like this. Yeah. If you shot the object in a slit that have double hole, then they will have double accumulation also in the screen. But when we are talking about small particle, remember when we are talking about modern, it is talking about quantum, and when we are talking about quantum, we are talking about small object. When we're talking about small objects, some of the small object also can behave like a waves. What is the difference between particle and waves? Let's see this example. For example, this is an electron. For example, it is a light. Light is a kind of wave. Yeah. When you shot a light into the same slit that have double hole here, what will happen in the screen? You will not have only two accumulation like the particle here. What will you see? You will see so many accumulation. For example, 1, 2, 3, 4, 5 accumulation here, because when it is a light, there will be interference of the light. Yeah, between one hole to the second hole, there will be interference of the light. So when we are showing like this, then we are talking about the behavior of the object as a waves. Now quantum say that we have to consider both of them. You have to consider that something is behave like a particles and also something behave like a waves. You cannot separate these two. You have to think both of them. Okay, so this is what Louis de Broglie said about the particles. Any question about this? Can we move? Okay. Now, what does it mean that a wave, why it is making a different, more than two accumulation here? Yeah, not like a particle. Particle only have two accumulation, but when it is light, which is a wave, it can make more than two accumulation here. Why it is like this? I told you before, it's because the interference. How it is happen, interference, this is showing you how the interference are happening, okay? So for example, if I have a wave here, yeah, let's say that is a water wave, yeah. If you have a water wave and there is a hole in the slit, what will happen? There will be another wave here from this first hole, and the second hole also make a different waves. So from one wave here, you will have two different waves in the after the slit. If you have two holes, if you have three holes, then there will be three different waves. And somehow in some place, the waves are interference to each other. As you can see here from the point here, point here, point here, point here, in here, in here, here. And also there will be some point here that there will be interference of the wave. Yeah. And the interference of wave is seen in the screen like a different accumulation. Because there are so many interference, of course, there will be so many interference in the wave. There will be a different accumulation, and this accumulation is denoted as a nodes. Nodes is this: the accumulation of the interference will make a nodes. So this node is look like the Bohr's atomic models. That's why I told you before that actually modern atomic model is the revision of Bohr's atomic model. Let's remember about Bohr's atomic models. Bohr's atomic model say that there's a nucleus in the middle, and there will be a fat where the electron are found. What is the name of this fat? Do you remember? What's the name of this fat?
Nucleus.
No, the
Oh,
nucleus.
shells.
Cell.
Yeah.
Cell.
The name of the fat is right.
Cell.
The other name it is energy
level.
So this energy level of shell is because of the nodes here, the nodes that made by the wave behavior of the particle. Yeah, the node is made by wave behaviors of the particle. So from here we understood that a small object, it can be particles and it can be also wave. Yeah, so that's why this is called as duality in a quantum. Okay, it is clear up to here? Clear, yeah? Okay, let's move then. Okay, after Louis de Broglie, the second scientist is Werner Heisenberg. Werner Heisenberg state about uncertainty principle. Uncertain means in bahasa
Ketidakpastian.
ketidakpastian ya. Ketidakpastian. Tidak pasti jadinya. Prinsip ketidakpastian. What is uncertain? Uncertain is the position of electron and also the movement or the momentum of the electron. Or momentum is also a velocity, can be also say that, or the movement of the electron. So it is not certain. The position and the momentum is not certain. Tidak pasti. Why it is not certain? I'm going to explain it by a video. Now I have a video here. Okay, let's click this video. Oh, can you see the YouTube or you see my presentation?
YouTube.
Yes, sir.
What you see now?
YouTube, sir. YouTube.
Okay, good. So,
Browser.
this video will show you the Heisenberg uncertainty principle. Let's watch together. Can you see the voice?
Yes, sir. Yes.
I'm doing an experiment that demonstrates Heisenberg's uncertainty principle. So here I have a green laser, and I'm firing it down towards the front of the room through a narrow slit. Now that slit can be adjusted, so it could be made narrower or wider.
So this guy is shooting a laser, green laser, to a slit that can be adjusted narrower or wider. So we will see what will happen.
And the laser spot is projected onto a screen behind it. So what do you think is going to happen to this spot on the screen as I narrow the slit? Well, let's have a look.
He adjusted
You
the slit here, become narrower. So it is a hole here, a slit, yeah. And he adjusted the slit here to become narrower.
Exactly what you'd expect. The spot gets narrower.
What you see, the spot is become narrower.
And narrower. The sides are getting cut off by the slit. Makes complete sense. And if you stop there,
you stop here, now it's become very, very small, yeah. It depends on the slit, okay? But it's not the point. We will see after this. After this, we will see the point.
You would never realize that Heisenberg's uncertainty principle is at work. But if you keep going, something strange happens. As you make the slit even narrower,
if you make the slit even narrower, the
spot starts to spread out.
What you see? The spot now.
The spot is spread out.
Not become narrower. It is spreading out.
Isn't that incredible? You're making the slit narrower, and yet the spot on the wall is getting.
As you can see, the spot is narrower. Become spreading out, wider.
Wider. The narrower you make it, the wider that spot on the wall becomes. To understand this, we have.
So this is something that uncertain, isn't it? Okay, I'm going to explain you about what does it mean. But before that one, I want one student to make a brief a summary about the experiment that the guys did. Let's see, Ken Panjalu. Can you summarize what the guys did in the video? You can use bahasa.
Yang video tadi ya, Pak?
Yes.
Ya.
What the guys did?
Oke, maksudnya, Pak.
Okay, let's see the other friend, Samuel Gabriel.
Yes, sir.
Yes, please.
Jadi tuh kayaknya kan tadi tuh celahnya tuh dipersempit, tapi malah jadi melebar kalau makin sempit. Gitu lah.
Okay, let's see the other one, Rifki. What do you think, Rifki?
What, sir?
Can you summarize the experiment that the guys did?
Can I use bahasa, sir?
Yes, you can use bahasa, please.
Jadi nanti kalau kayak dimepetkan akan menjadi lebih tipis, tapi pas sudah tangan mepet nanti bakal nyebar, jadi kayak melebar gitu, nggak menipis lagi gitu.
Yes, so there is an uncertainty there, isn't it? First, it will become narrower, but at some point it will become wider. So that's why it is uncertain. The position, when you see the slit is telling you the position of the object, and the movement of the object when it is projected to the screen. It is the movement of the object, the momentum of the object. As you can see, it is changing. At first, when it's become narrower, it's the screen also, the projection and the screen also become narrower. But at some point, when it is very, very narrow, what will happen? The projection will become wider. So that's why it is not certain. That's why it is called as uncertainty principle. Okay? So that's why it is called as uncertainty principle by Heisenberg. It is clear, uncertainty principle? Okay? Clear? Can we move? Okay, let's move then. Okay, this is the explanation about the experiment that we did, the guys did in the video. So actually here we have the split here with the hole here. It shows you that this is the position, yeah? When you make the position, the slit is narrow, then the position is changing. When it become wider, the position also changing. And depends on the position, the momentum here, it means the movement of the particle is also changing. First, it is become narrower as the slit become narrower. But at one time, when the slit even become narrower, then the projection in the screen become wider. So this is uncertain. You cannot find at the same time the certain position and momentum or movement. So it is uncertain. You cannot make it certain. Yeah, position and momentum. Okay, let's move. Now the last one, the last scientist, it is Scrodinger. Scrodinger quantum mechanic theory. Scrodinger is somehow it is what make the conclusion of the Louis de Broglie and Heisenberg theory. So Scrodinger wrap it up, yeah, wrap the Louis de Broglie and Heisenberg, and he after that made one theory called as a quantum mechanic theory. Okay, I'm going to explain about Scrodinger quantum mechanic theory, which is the conclusion at the last that make the quantum mechanic theory with the video. This is the video, the second video for today. By the way, did you heard about the cats? Scrodinger cats?
Yes, sir.
Did you heard about Scrodinger cats?
Yes, sir.
Yes, sir. I have heard it.
In physics class? Where did you heard it?
From YouTube.
From YouTube. Okay, good.
You're watching TED, sir?
Okay, now we are going to talk about that cats. Actually, Scrodinger is not doing the experiment with the cat. He just think that if I put the cat in the box, what will happen to the cat? So it's only in the mind of the Scrodinger. Actually, he didn't do the experiment. Yeah. Can you hear the voice?
Is one of the founders of quantum mechanics, but
Can you hear the voice?
Sir, we can hear the voice, but we still in your presentation, sir.
Okay. So I have to go back here, share screen. Okay, now. Okay, now can you see?
Yes, sir.
Okay, good.
Yes, sir.
Okay, now let's see what Scrodinger.
Austrian physicist Erwin Schrödinger is one of the founders of quantum mechanics, but he's most famous for something he never actually did, a thought experiment involving a cat. He imagined taking a cat and placing it in a sealed box with a device that had a 50% chance of killing the cat in the next.
So what Scrodinger did, Scrodinger Sting actually is not doing this experiment. He just stores that if I have a cat and if I put the cat into a box, then I put a devices that can kill the cat, then the possibility for the cat to be die or alive is 50%, 50%.
Next hour. At the end of that hour, he asked, what is
Now the question is,
the state of the cat?
after this experiment, what will happen to the cat? This is my question. After the experiment, what will happen to the cat? Let's ask the question to Al-Fahrezi. Al-Fahrezi, what do you think, Al-Fahrezi? What will happen to the cat after the experiment? Where's Al-Fahrezi?
It will be alive.
Is alive?
Well, I think so.
Yeah, you think that is alive? Good. Okay, another student, Rifki Surya, what do you think?
Life.
It's live. Why it is live, Rifki?
I don't know.
Okay, let's go back again to the video. Okay.
Common sense suggests that the cat is either alive or dead. But Schrodinger pointed out that according to quantum physics, at the instant before the box is opened, the cat is equal parts alive and dead.
Yes, according to the quantum physics, when you before you open the box, you will think that the cat inside is either live or die. So it is between life and die. When you will make sure that the cat is die or live, you will make sure that when you open the box, then you will see that the cat is live or dead. And at that time, you can say that, oh, the cat is live, or the cat is died. But when you didn't open the box, or you didn't see it, you cannot say that the cat is live or died. But you can say that the cat is between life and dies. So this one is very, very relevant to study about quantum. Why? Because quantum is study about anything or small object that you cannot see. That's the problem. You cannot see the electron. You cannot see the atoms. That's why it is like the cat. You cannot see the cat. Then you cannot say that the cat is live or die. What you can say that the cat is between life and die. So there is a probability is going around here. The probability the cats can be live and the cat can be die. There's a probability, kemungkinan, yeah. So when we are talking about quantum is talking about the probability, because you cannot see the atom and you cannot see the electron. So it is like the cat in the box. You cannot see the cat in the box, whether it's live or die. But there is a probability the cat to be live, and there is a probability the cats to be die. So this is quantum, talking about something that you cannot see. It's very small.
At the same time, it's only when the box is opened that we see a single definite state. Until then, the cat is a blur of probability.
Yes, it is a blur of probability. So we are talking only about the probability, kemungkinan, probability.
Half one thing and half the other. This seems absurd, which was Schrodinger's point. He found quantum physics so philosophically disturbing that he abandoned the theory he had helped make and turned to writing about biology. As absurd as it may seem, though, Schrodinger's cat is very real.
But it is a probability, but it is real. Yeah, it is real. It's happened. You have to think that there is a cat inside the box. But what is the state of the cat? It is alive or die? We cannot know. It is a probability. Okay.
In fact, it's essential. If it weren't possible for quantum objects to be in two states at once, the computer you're using to watch this couldn't exist.
So it is possible for quantum to be in two states, yeah, in at the same time. Not like cat. Cat cannot be live or die at the same time. Either it's live or either it's die. But in quantum theory, we are going to think that a particle can be in two states at the same time. So this is the theory about the quantum. You are going to think about that. You're going to think that object is like a particle and like a wave at the same time. Although it is something difficult to think that how can an object become a particle and also become a wave? If it is become a particle, then it's difficult to become a wave. If it is become a wave, then it is not a particle. But actually, when we're talking about quantum, both of them we are going to think at the same time. Yeah. So I'm going to stop here, guys, for today because we have only under 1 minute to finish the lesson. So next lesson we are going to continue with the Scrodinger experiment about the probability. Yeah? Scrodinger actually is talking about the probability of finding something or probability of knowing the behavior of the electron in the atoms. So it is only probability like the probability of knowing the cat live or die inside the box. So that's why we are talking about the probability in quantum theory. Okay, that's not for today. Do you have any question? Okay, if you don't have any question, let's stop here. In the second hour, again, I'm going to give you assignments that you have to do. And then after that, last 10 minutes, there will be, again, post-test about the lesson that we see at the moment in lesson number 16. Okay? See you next lesson. Inshallah. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
warahmatullahi wabarakatuh.
Warahmatullahi wabarakatuh.
Have a nice lunch.